Today, I'm going to show you how to turn this ESP32 touchscreen setup into a real dashboard UI control panel using the TFT ESPI library. We'll cover how to build buttons, display live sensor data with text and numbers, and also create visual elements like line graphs and gauges. In the last video, we got set up with this 3.2-inch TFT screen. We're now ready to start using it as a dashboard in our projects. In this basic example, we control 8 NeoPixel LEDs on a simple UI with buttons and sliders. Using a touchscreen eliminates the need for physical inputs like buttons or potentiometers. It makes it really easy to interact with your ESP32 or Arduino projects. Let's start with virtual buttons, because that's the foundation of most interfaces. On a touchscreen system like this, a button is not a real UI object. We draw different shapes using the functions inside the TFT ESPI library. We create it visually first using a filled rounded rectangle, then we're layering text on top. To make it interactive, we define a hitbox. That means we check if the touch position is inside the button area. When a touch event happens, we compare the touch X and Y values against the button boundaries. If your finger is inside the rectangle, we trigger an action. We are reading raw X and Y coordinates directly from the touch controller. Now, once buttons are drawn, we can make them do whatever we want. So for example, one button can toggle LED power, another might switch modes, another could reset values. That's how a dashboard becomes functional instead of just visual. If you press the button once, the ESP32 might think you tapped it 10 times in a millisecond. The fix? We implement a timer. We tell the code, once a touch is detected, ignore all other touch signals for the next 200 milliseconds. This is called debouncing. A slider is just a horizontal mapping of the touch position. We take the X coordinate and map it into a range, in this case 0 to 100. As you drag your finger across the screen, the values update smoothly. The best way to learn is to take a look at the Arduino IDE sketch. The functions for drawing the shapes are specific to this library and will vary if you're using a different one. The Arduino IDE demo sketch can be downloaded with the link in the description. For drawing numbers and text, the TFT ESPI library provides several different pre-baked fonts so you don't have to design characters manually. You can implement these by including the font number directly in your drawing command. For the cleanest UI, it's always better to use a larger native font number like 7 or 8 rather than stretching a smaller one. Always include the text, the XY coordinates, and the font number in the line. Think of your screen like a stadium scoreboard. The word score is painted on the wall. That's your static text, but the numbers are dynamic digits or text that change. Draw static labels like battery or temperature once in your setup. Drawing them in the loop wastes processing power. Keep your dynamic data in the loop to show changing data. Linking your variables simply means passing a dynamic variable name directly into your drawing commands instead of using a static hard-coded string of text. By placing the variable inside a function, the screen automatically updates the displayed output whenever the data in the variable changes during the program's loop. This connects your live sensor data or calculations to the visual interface, ensuring that the display reflects real-time information as the code processes it. The TFT ESPI library has an important command for drawing flicker-free text. By providing a second color, the background, the letter acts as its own eraser. It paints a new letter and fills the empty space with black at the same time, instantly wiping out the old number. In the TFT ESPI library, text padding is a technique used to prevent ghosting or leftover pixels when updating rapidly changing text, such as sensor readings. When you print a new string over the old one, if the new string is shorter, the extra characters from the old string remain on screen. Set text padding fixes this by drawing a fixed width background area that is cleared every time text is drawn. When you call a drawing function, the library fills a rectangular area to the specified width with the background color before drawing the text. The height of this padding area is determined automatically based on the font being used. You must use a foreground and background color using set text color for padding to work. It is best to set the padding to the maximum possible width your text might reach. You can use the text width function to calculate this dynamically. Always reset padding to 0 after drawing your dynamic text if you plan to draw other strings that shouldn't be padded. TFT ESPI library has built-in colors, but if you want custom colors, you can use this line here. Instead of just printing numbers or text, we can turn that data into visual elements. Let's use a gauge display. A gauge is basically a visual representation of a value, so instead of just saying 24 degrees, we map that temperature value into a filled arc or bar. As the temperature increases, the gauge fills up more. This gives you instant visual feedback. We can make simple gauges with code by drawing circles and lines. For more advanced gauges, we have to use custom graphics. For this example, we're using an animated GIF with separated frames. Values from the sensor are linked to certain frames inside the GIF. If you want to see how to show GIFs on the display, check this video here. Now we add a line graph, which is where the UI starts to feel like a real monitoring system. We can store readings in an array over time, shifting old values and adding new ones continuously. We then draw the line between each point on the screen. That creates a scrolling graph that shows how sensor data changes over time. If you clear the whole screen every time a sensor value changes, that causes flicker. The black box or blanking rectangle method is a beginner-friendly way to update sensor readings by using TFT fill rectangle to paint a small solid block of the background color directly over the old text before drawing the new value. By targeting only the specific area where the numbers sit, you avoid the distracting flash caused by clearing the entire screen, though it isn't perfectly seamless. If your display updates very quickly, your eyes will catch the tiny gap between the erase and draw steps, resulting in a local flicker where the numbers seem to blink or stutter in place. The pro way to do this is use a sprite, which is essentially a chunk of RAM treated like a mini screen. Create the sprite in memory, draw your background icons and text inside that memory box, and then push the entire box to the physical screen in one giant burst of data. Since this math happens in RAM, the physical screen only updates once. This makes animations look incredibly smooth. This basically covers how to make a simple UI with the TFT ESPI library. Once you understand these UI building blocks, you can turn pretty much any ESP32 project into a full control panel or dashboard. If this video helped you out and you want to see more tutorials, make sure you subscribe because we're just getting started. As always, thanks for watching.